All right, welcome back to The Explainer. Today we are jumping right into something big, a paradox that's playing out in the software world right now. On one hand, you've got this incredible, super fast AI coding, and on the other, you have these ancient corporate systems, some of them decades old, and when they meet, well, it's a collision. Let's get into it.
So let's start with the term that really kicked all this off. It comes from the AI researcher Andrej Karpathy, and he calls it vibe coding. And, it's pretty much exactly what it sounds like. It's about getting into this creative flow state where you just describe what you want in plain English, and boom, the AI agent handles all the tedious, nitty-gritty syntax and starts building for you.
And that right there is the core problem we're talking about today. I mean, what does happen when this cool, new, fluid way of creating things smacks head on into those 20-year-old systems? You know the ones. They're rigid, they're super complex, and probably no one even remembers how they fully work anymore. This is exactly where the whole vibe coding dream gets a very serious reality check. Now, to be clear, vibe coding really is a game changer. It has totally shifted how development gets done. Instead of being down in the weeds, painstakingly typing out every single line of code, developers are now acting more like, well, movie directors. They're having a conversation, guiding their AI partner to get the scene just right. The focus isn't so much on how to write the code anymore. It's all about what you're trying to build and why. And yeah, this slide just nails the promise of it all. I mean, think about it. We're moving from a world where you had to get every single semicolon perfect to a world that rewards your big ideas, your logic, your architectural vision. The goal is no longer just writing code, but clearly expressing your intent. And when you hear about things like a one-click vibe deploy, man, it sounds like pure magic. But here it is. Here's the paradox. You've got startups, right? They can spin up entire applications from scratch using this stuff. It's amazing. But then you look at the big established companies, and they are just hitting a brick wall. They have these huge old legacy systems that desperately need AI to get modernized, but those same systems are so outdated, they actually prevent the AI from working properly. It's a total catch-22, a strategic deadlock. And this table really breaks down why it's such a mess. It's a fundamental mismatch. The new AI agents, they're like hungry race cars. They need high-octane, real-time fuel. We're talking data, APIs, everything happening right now. But the legacy systems, they're more like an old farm tractor that just chugs along and processes everything once a day, overnight. You can't ask an AI to make a smart decision with data that's 24 hours old. It just can't work. This is what people are starting to call the latency trap. In all of that friction, it leads to this really predictable pattern of failure. Experts are even giving it a name, the 18-month wall. It's a story we're seeing play out over and over again. It starts with pure euphoria. For the first few months, teams are shipping features faster than they ever thought possible. But then, the cracks start to show. The AI-generated code starts piling up, nobody's really vetting it, and the system becomes brittle. Debugging turns into an absolute nightmare, and then, somewhere around a year and a half in, bam, you hit the wall. Progress just grinds to a halt.
So what is going on here? Why does this keep happening? Well, if you start to peel back the layers, you find some really surprising, almost counterintuitive truths about what AI-assisted productivity actually looks like in the real world.
Get this. A recent, pretty rigorous study found that even though developers felt like they were flying along, they were actually 19% slower. Slower! The reason? A hidden cost that people are calling a verification tax. It's all the time and the mental energy it takes to go back and audit the AI's work, to debug it, and to correct the code that looks totally plausible but is actually flawed. And as if that's not enough, it gets worse. The code isn't just buggy, it's often a massive security risk. Think about it. These AIs learn from all the public code out there on the internet, and a lot of that code is not great. So the AI learns those bad habits and just replicates them. We're now seeing that nearly half of all AI-generated code has at least one security hole in it. For a big company, that's not just a problem, it's a potential catastrophe. So you add all of this up, and the result is just staggering. A 70% failure rate for these big enterprise AI projects. 70%. And the crazy part is, it's not because the AI itself is bad. It's because everyone gets so hyped up about the speed that they skip the boring but absolutely essential prep work. Getting the data right and making sure the systems can actually talk to each other. And if you look at what kinds of security flaws we're talking about, a pattern emerges really fast. We're not talking about some exotic, super sophisticated new attacks. Nope. The AI is consistently making the classic rookie mistakes, things like forgetting to validate what a user types into a form, or accidentally leaving secret credentials just lying around in the code. These are the exact kinds of things an experienced human developer learned to avoid years ago. So, that brings us to the million-dollar question, doesn't it? If you have an AI cranking out flawed, insecure code at machine speed, who acts as the guardian? Who's the gatekeeper for quality and security? Who applies the brakes? Well, the answer isn't to just get rid of the AI, not at all. The real solution is to embrace a two-stage process where your senior developers are more valuable than ever. They aren't being replaced, they're being promoted. Their job is no longer to write everything from scratch. They become the architects, the curators, the final checkpoint. They provide the judgment and the critical context that an AI just doesn't have. So, what this really means is that AI isn't replacing developers, it's sorting them. It's changing what skills are in demand. The hot jobs now aren't about writing simple functions. They're about systems thinking, about ML ops, and about security. These are the skills of that essential human in the loop, the person who ensures the AI's incredible speed doesn't drive the whole system right off a cliff. Now, to make this whole two-stage process actually work, companies are building a really critical piece of infrastructure, the AI adapter layer. Think of it like a universal translator and a safety buffer all rolled into one. It sits right in the middle between the chaotic creativity of the AI and the rigid, fragile world of those legacy systems, making sure they can talk to each other without breaking anything. And having that adapter layer, that's what unlocks a real strategy for modernization. Instead of a big, risky rip and replace of the old system, which almost never works, companies can take a much smarter, incremental approach. They can wrap old systems in modern APIs, gradually strangle old pieces with new ones, or just liberate the data first. It gives you a practical step-by-step roadmap to get there. Of course, all this technical work needs some serious human oversight. You need rules of the road. That's why companies are forming these integration centers of excellence, or ICOEs. This is basically the governance layer, the team that sets the rules, which AIs are approved, what data they can access, and how their performance and errors are tracked. The rigor here has become so deep that it's even created a whole new discipline, prompt ops. This is wild. It means you treat the prompts you feed to an AI not as some casual questions, but as mission-critical pieces of code themselves. They get put into version control, they get security audits, they go through peer review, the whole shebang. So what this all leads to is a fundamental shift in perspective. That initial rush of vibe coding was all about raw speed, but the mature, enterprise-grade approach, that's about governed autonomy. The goal is to safely manage these incredibly powerful systems, not just to crank out features a little bit faster. And ultimately, that's the new reality. The most valuable skill in this new era isn't how fast you can type. It is that uniquely human ability to apply wisdom, judgment, and architectural taste to the incredible speed and scale of a machine. That is how you solve the vibe coding paradox.